Hi, and welcome back to Dalton Does DevOps. I'm Dalton, and today we're actually going to be doing some CDK. So, to do that, we will get started by creating a new directory, and we'll go ahead and we'll title that Demo S3 CDK. And once we do that, we'll open that up. We'll open ourselves a command prompt. And now we're going to initialize the CDK project. Now, you'll remember me mentioning that there are certain directories and files, like the lib directory and the bin directory, and package.json, cdk.json, etc. This command that we're about to run will actually set this up for us. And that command is cdk init app -- language equals TypeScript, and then we just hit enter, and then CDK will go ahead and do all that stuff for us. Now obviously this is predicated on you having installed all of the tools and applications that I went over in the last episode, so if you haven't installed those, please go ahead and install those, and then you'll be able to run this for yourself. But aside from that, as a little aside, you'll see that I said CDK init app. That is creating our CDK app file structure. There is a second one that you could run, which is called CDK init construct. And that will actually create a construct structure instead of an app structure. But for the sake of this demonstration, we're going to be using the app structure. So we're going to go ahead and open VS Code, and we're going to open that directory that we just created. So let's go ahead and open that. And we'll go ahead and open the demo s3cdk.ts file and the demo s3cdk stack.ts. Now, I went over this in the first episode as well, but quickly. The demo s3cdk.ts, this is your app entry point. So this is where CDK will look when you go to run things like synth and deploy and diff. And demo s3cdk stack is where you define your resources. So for this example, we're going to be creating an S3 bucket. So what do we need to get started? Well, the first thing we're going to have to do is we're going to need to import the S3 construct from the CDK lib. And to do that, we will go import all as S3 from, I'll do single ticks to keep it consistent, AWS CDK lib / AWS S3. And once we've done that, we now have access to actually creating a bucket. So we'll go const demo bucket equals new s3.bucket. And we'll give it a scope of this and a name of demo bucket. And then we can define the props that we have access to. So if we press Control Spacebar, it'll bring up the IntelliSense. And you can see that we have access to this list of props. So usually the ones that have blue in front of them come from the construct that we're importing. So you can see we have access control, bucket name, encryption, metrics, object lock, etc., etc. Another way to look at this is actually by looking at the CDK API docs. And you can see in the API docs, which I will link in the description, it gives you some examples of what a default bucket might look like. This goes for any service that has an L2 construct. You may be asking, what is an L2 construct? An L2 construct is something that has already been, for lack of a better word, CDK-ified, and it gives us access to, IntelliSense and things that have already been sort of pre-created for us. An L1 construct does not have that. You've got to use raw CloudFormation to do anything in it. So an example is Identity Store. And you can see to do anything in Identity Store, you actually have to import a CloudFormation resource. So for this example, to do a group membership, you are importing it from CFN group membership. But for S3 and most of the services that we're using, we won't need to worry about that because we'll be using L2 constructs. So if we scroll down in the API docs, you'll see that we get a nice table of construct props. So we get the name of the props, we get the type of the props, and description. So if you don't want to go through the IntelliSense and add that add each thing and then hover over it to see what it is, for example, bucket name, we hover over bucket name and it says physical name of this bucket assigned by CloudFormation, which is recommended. But if we look at bucket name here, physical name of this bucket. So it's the same thing, says it's a string, and you can do that for other things. So you've got encryption, you've got enforced SSL, you've got lifecycle rules. It says, it's expecting an array of lifecycle rules. So it's more of a at a glance thing. You can see more about what you're trying to accomplish. So, it's the next best thing to go clicking through the console, really. So if we go back to our CDK, we'll start defining some props. So bucket name is a nice easy one, and we'll call it demo-bucket. And at this point you might be saying, Dalton, why are you defining the bucket name when you already have defined the bucket name? And you'll see that this is capital D, capital B, demo bucket, and we have lowercase d hyphen lowercase b, demo bucket. And the reason for this is because it helps it look nicer in the console. Now, you don't need to do this, and another use case is if you have a specific bucket name for some reason that you need to use, you can also do it here. But let's have a look at what this looks like in the template. So if we type CDK synth, and that will go ahead and generate our CloudFormation template for us, and we'll get to see, so we'll save that and we'll run it again. And we'll get to see what CloudFormation template this is actually going to push to the CloudFormation console and what it's going to create. So if we have a look at the template here, we will see that it is a name of demo bucket and a random string. Now, that's great for most use cases. It will also be appended with, or prepended with, the stack name. So in this case, it would be demo s3 cdk stack / demo bucket random string, which, as you may imagine, if you've got hundreds of buckets, may not be the easiest to filter through when S3 expects exact names. So what does that look like if we specify the bucket names? We'll uncomment that out and we'll synthesize our stack again. And we'll see what that looks like now. Alright, so that's finished. And we'll see that we actually get a property of bucket name and demo-bucket. So in the console, that will show up as demo-bucket, not stack name demo-bucket random string. Now, one thing to keep in mind with bucket names, S3 bucket names, is that they are globally unique. Not account unique, not region unique, globally. So that's every account that exists. It must be a unique bucket name. So that's where you can run into trouble. So highly unlikely that we will deploy this and be able to get demo-bucket with all of the demos that are available. So we will need to do some sort of random string. But for the sake of this example, we'll leave it as demo bucket and we'll move on to some more props. So some nice basic props to enable are block public access. And if we hover over this, we'll see that the default for block public access is new buckets and objects don't allow public access, but it can be modified through bucket policies or object permissions. So if you want to make sure, if you want to feel good knowing that this is 100% blocked, you can define it yourself. And it says how to do it. It's an s3.blockPublicAccess. So if we copy that and paste that there, we then get a dot block all. So now we know for sure that those are going to be blocked. Now, some other things, security related things we could look at. Let's look at encryption. So for encryption, it's expecting S3 bucket encryption type. And you'll see that the default is KMS if encryption key is specified or S3 managed otherwise. Now, S3 managed is perfectly fine if you have compliance requirements that mandate that you need to provide your own key material. Then you can create a customer managed key in KMS, provide the key material, and then use it here. But for the sake of this example, we'll just use S3 managed. So we'll go ahead and specify that one. And a couple more. Let's see. Where are we? We'll do removal. Nope, not that one. Removal policy. So if we start typing this, removal policy. Yep, removal policy. And this is what happens to the bucket when the stack is deleted. Now, if you have a test deployment, a dev deployment, you may not want to leave the buckets behind because they will really pollute the console list, or just even the CLI list. It will pollute that. So for dev and testing, you may want to destroy the buckets. For production, you may want to retain the buckets. Or, you know, in certain circumstances, if there's data that can't be recreated for even testing, you may want to retain it. You may never want to delete the buckets. There may be a compliance requirement, an audit requirement. There's lots of different things that may necessitate retaining buckets. But for these demo examples, we're not going to be retaining them. And we'll do one more. Let's see. Versioned. Versioned is for the objects in the bucket, For the objects in the bucket, versioning essentially creates different versions of those files. So if you upload the same file name, it will create another version, a newer version of the same file, instead of overwriting the existing one. So you can always revert back to the former one if you've overwritten it. If you've deleted a file, it's not actually deleted. It has a delete marker inserted into it. And that means that you can get back your deleted items. Combining this with something like a bucket policy that denies certain actions can make it so that the objects in your buckets and the buckets themselves are pretty locked down. So for this, it's expecting a Boolean. So we'll just say true. No, we'll say false for now, because we're not going to have anything that goes in there. Now, that will conclude episode 2 for our basic demo bucket. If you found this content valuable or you like this sort of stuff, please feel free to like and subscribe. This will be available on the GitHub. It will be linked below, and so will the API docs. And I will see you next time.